Good morning, everyone. Myself, Dr. Veera Pratap, Associate Professor, Department of ECE, ATME College of Engineering, Mysore. So today I am going to explain a MATLAB program which is Gram-Schmidt Orthogonalization. The aim of the experiment is to find the orthogonal basis vectors for the given set of vectors and plot orthonormal vectors. Okay, this is the aim of the experiment. So what is the objective of the experiment? It is to derive the orthogonal basis vectors from a given set of non-orthogonal vectors using Gram-Schmidt orthogonalization process. Usually three vectors u1, u2, u3 will be given. We need to find which are non-orthogonal vectors. By using Gram-Schmidt orthogonalization process, we need to find v1, v2, v3. For that, Gram-Schmidt orthogonalization process has a set of formula, and the second objective is to compute corresponding orthonormal vectors by normalizing the orthogonal vectors. That is, we need to find e1, e2, e3. Even for that also we have a set of formulas, and finally we need to visualize this orthonormal vectors by plotting them to understand their spatial distribution. On a 3D plot we are going to plot this. Okay, so this is the objective of the experiment. So first we need to learn what is orthogonal and orthonormal vectors. So what is orthogonal vectors? If we want to set two vectors are orthogonal to each other, means they should be perpendicular to each other. That means that dot product need to be 0. Okay, so what is orthonormal vectors? If two vectors are said to be orthonormal, then it has to be unit length. For example, if you consider u is 1 comma 0 and v is 0 comma 1, those dot product should be 1 into 0 plus 0 into 1, which leads to 0. Okay, then we can say both are orthogonal to each other. Okay, next, what orthonormal means? If you take the magnitude of their length, it should be 1 square and square root. 1 square plus 0 square. Okay, 1 square plus 0 square is 1. Square root of 1 is 1. Similarly for v, square root of 0 square plus 1 square. Okay, so which is also 1. So we can say both are orthonormal to each other. Next, what is the process? The Gram-Schmidt process is we need to take the first vector v1 as u1. u1 is usually user defined u1, u2, u3. So normally we are going to consider v1 as u1. What's the next step? Subtract the projection to make the second vector orthogonal. So how we are going to find v2? So we have a formula, v2 is equal to u2 minus projection of v1 on u2. Okay, next, step number 3, projection. Subtract projection to make the third vector orthogonal. So v3 is equal to u3 minus projection of v1 on u3 minus projection of v2 on u3. That is the third step. What is the fourth step? Fourth step is we need to normalize to get the orthonormal basis. That is, we have a formula, ei is equal to vi by length magnitude of vi, where I is equal, I can take a value from 1, 2, 3 and so on. Okay, this is the process. Next, so what is the given vectors? So the given vectors are u1 is equal to 1, 1, 1, u2 is equal to 0, 1, 1, u3 is equal to 1, 2, 1. So for these given vectors we are going to apply Gram-Schmidt to derive v1, v2, v3. Okay, next, so on performing the computation we are going to obtain v1, v2, v3 as shown. Okay, next, this is orthogonal. Next, for orthonormal basis, so for doing normalization we are going to obtain e1, e2, e3. Okay, so we need to match the theoretical values with practical values by writing a code on MATLAB. Okay, so I'm going to explain the MATLAB code step by step. Okay, first we need to initialize the given vectors u1, u2, u3. Okay, next step is we need to initialize v1 is equal to u1. Okay, next step is we need to write a formula v2 is equal to u2 minus projection of v1 u2. So it is dot product of, it is a detailed this thing, okay, dot product of u2 v1 divided by dot product of v1 v1 into v1, okay. Step 3 is to find v3. Next step 4 is we need to do the normalization, okay. E1 is equal to v1 by normalization of v1, E2 is equal to V2 by normalization of V2, E3 is equal to V3 by normalization of V3. Next, we need to display both orthogonal basis as well as orthonormal basis. That is, we need to display V1, V2, V3 as well as display E1, E2, E3. Next, step 5 is to plot orthonormal vectors. Okay, so I'm going to explain each and everything in detail. Okay, so what does this figure do? Figure will opens a new figure window. Okay, next, the next keyword is Weaver 3 0 0 0 e1 comma 1 e1 comma 2 e1 comma 3 are line width 2. What does this Qver 3 will do? It will plot a 3D arrow. Okay, next 0 0 0 indicates all the three arrows starts from origin. Okay, next e1 comma 1 e1 comma 2 e1 comma 3 are the components of first orthonormal vectors e1. Okay, if you remember, it is 1 by root 3, 1 by root 3 and 1 by root 3. E1 comma 1 is 1 by root 3, e1 comma 2 is 1 by root 3, e1 comma 3 is 1 by root 3. Next, what is that R? My this thing, orthonormal basis, first one is going to be displayed in red color. Okay, R. Then what is line width 2? I want my line to look thicker. Okay, it is user defined. You can increase or decrease the line width. Okay, the next command is hold on. What this command will do, it will keeps this vector on the plot, so more vectors e2 e3 can be added without erasing it. Okay, next, so the first vector will be drawn on the red. Similarly for the second one, okay, it will be displayed in green. Third one will be displayed in blue. Next, labeling. So we have three parameters x, y and z. All the three will be labeled as x label, y label and z label. Next the command is grid on axis equal. What is this grid on is going to do? It will show the grid lines for easier reference, and axis equal ensure that all has a equal scaling. Okay, next command is legend e1 e2 e3 adds a legend box identifying each color. Red is e1, green is e2, blue is e3. Finally, on the figure, it is going to display orthonormal basis vector, and it is going to add a title on the top of the plot, that orthonormal basis vector. Okay, so this is the explanation. I'm going to show this on online MATLAB. Okay, so come to online MATLAB window. Here, open a new script. Okay, I've already copied the program. I'm just going to paste it, which we have already discussed in the PPT. Okay, next, go to save, save as, save it as experiment number 5. Okay, just click save. Okay, next, after saving, go to run. So you can just see, let us go calculated orthogonal basis vectors 1 1 1, this one minus 0.667333 and